Hey everybody, welcome back to the shop. So we're going to go ahead and get started on our second part for the Cincinnati milling machine repair. And we're going to go ahead and get to our shaft now. So the previous video, just in case you missed it, we repaired the bore on the coupling right here. We put a fresh bore in there and broached a new keyway that goes on the end of the shaft. And now we have to fix the shaft so that it fits the coupling properly. And the way that I'm going to do that is I'm going to use my Eutectic Teradyne 2000 flame spray welding kit to do that. This is a heat treated shaft, and I had shown previously, I did some testing on it, and it's on average around 43 to 45 Rockwell. So it is a heat treated shaft. It's got some strength to it, and I want to make sure that I don't put any temper into it. And by using this process, it should not damage the shaft at all. It's not going to damage the threads or anything on that. So what we're going to do is set this up, and since this is the journal that we're going to be fixing, I'm going to do a very light undercut across here. We're going to leave a shoulder on the end, and then we won't quite go to those threads, but we'll go right past the keyway. Undercut it, cut a nice, a very fine pitch thread across there, and then we'll do our build up. So to protect these other surfaces, I use a masking compound. I want to show you what I'm using because I usually have a lot of people asking me what it is I'm using. So this is the masking compound by Eutectic. It's called Solution 103. Masking compound prevents adhesion of coatings to adjacent surfaces during application. So all you do, it's just kind of like paint. I just take a little acid brush, dip it in there, and then when this is spinning, you just coat it, and then you have to let it dry. And then once you do that, then you do your undercut, and then you do your flame spray. The material that we're going to use is this right here. I like using the 21022. This is good for most of my applications anyway. If you're doing a basic shaft repair, a bearing journal, a seal journal, or any kind of journal on a shaft that needs to be fixed, this is a good choice to use right here. It machines well, it sprays well, and it finishes really nice too. And I don't think I've ever showed what this stuff looks like, but it just looks like powder. I'll go ahead and we'll dump a little bit out right here in this cap so you can see it. This stuff is expensive, so you don't want to waste it, but that's all it is. It's just metal powder. So there's different alloys mixed in there. There's different fluxes. There's all kind of ingredients in this that I don't know about that makes this stuff work its magic, all right? But whenever this stuff flows through the torch and into where the flame comes through, it melts the powder into little particles, blows it out, and then it microscopically attaches itself to the work surface there. And as that piece is rotating, as this is rotating around, you're just continuing to build it up larger and larger as you continue to spray it. So that's the powder right there. And here's the book showing, there's my system right there, Teradyne 2000. They have several other systems, but this gives you an idea. You know, this is some of their sample photos of these systems in work doing coatings and build-up work for different types of repair. This stuff is actually a lot more common in heavy industry than people realize. You just don't see it. It's not an everyday thing that you see. It's not very common to be seen in the public. It's sort of behind the scenes, a lot of different products that they use to repair industry out there. So we'll go ahead and go to the lathe, get this guy set up, and start doing our prepping, our undercutting, and get this thing ready to spray. Okay, I've got the shaft chucked in here in the 6 jaw, and we'll put an indicator on here so you can see this is the bearing journal right here. Go ahead and put the indicator on there and see what kind of run out that we have. And showing you that it is on there. So I'm getting not even a half a thousandth run out. So I usually have really good luck chucking on this thing. As long as I get it centered well with the scroll, it'll usually center up really well within about a half thousandth. So that's doing pretty good. I want to go ahead and just look at this end here too. The end that we're going to be repairing. Let's see what it's showing out there. A little bit more, but some of that's probably wear as well. It's showing about a thousandths. All right, so that's good to go. And we'll just turn it right there. I may not need a center, but when we go to do our undercutting our threads, we may put a center in there just to help support it if it tries to squeak on us a little bit, because this is a little bit tough. It's not super hard, but it's a little bit. So let me get set up, and we'll get this thing cleaned and masked. You just want to make sure that there's no oil. I'm just going to put a rag there to kind of catch the spray. You always want to make sure that your workpiece is completely clean of any oil and grease on there at all. So I'm going to use this Super Degreaser Plus right here. This is non-chlorinated. Just takes a little bit. I just want to make sure that all the oil is off. There's no oil up in those threads. There's no oil in this keyway or in the center. That should be good right about there. Pretty quick drying stuff. All right, just giving our masking compound a good shake. We'll turn it on. I'll put the rag back down there just because it'll probably catch a few of these drips. That's what our masking looks like. I always have people wondering about that. Main area of focusing on is these threads. So I'm going to put 2 good coats on here. But even, you usually end up getting a little bit trying to stick there, but it's not a problem because I can go in there with a tool bit, line up on those threads, and as soon as it starts touching it, it just peels right off there. But I'm also going to make sure that I put some on this bearing journal. But I won't need to go any further past that because that spray is not going to reach all the way over here where those splines are. And we're going to be going all the way to the end of that shaft, so there's no reason to put it on the end of the shaft there as well. It's not going to get in that center is what I mean. So I'm going to let that dry, and then I'm going to coat it one more time. Let's go ahead and start our undercut now. Leave just a little bit right towards the very end of the bevel there. There's our touch off. Fed in 10 thousandths. Ideal conditions for turning. Going to interrupt the cut, plus it's a tough material, but hopefully that threading tool will hold out. Close to those threads as I can get. Our undercut looks pretty good. That's just the fuzz that you see on the surface there. I'll have to blow that off whenever we're ready to do our spraying. So now we're going to go back in there. I'm going to hopefully just make one pass with a thread for our undercut. I've got the machine set at 24 threads per inch. Fifteen thousandths. All right, there's our undercut and our thread, and that should be sufficient right there. So now we're going to go ahead and set up and perform our flame spray buildup. So I'll admit that I goofed up here, and some of you guys have probably caught on to this before I had got to this point to mention it. I forgot to mask the Woodruff key in here. I'm just so used to never having these keys in the way that I just didn't even think about it. I was so focused on the threads and the bearing journal that it just slipped my mind. It was a total goof up, but that's the kind of stuff that can happen. But I'm glad that I caught that before I started spraying it, because that stuff will try to go down in there and stick, and I don't want it to do that. So I'm gonna have to redo what you just saw. I need to go in here with the brush and mask the inside of this Woodruff key on the sides and make sure that it doesn't stick inside there. And then I got to come back and clean this up again, because you know you can't have any masking out there either. I'm just going to take a very minor amount off that surface and then line up with that thread again. I've still got the lead screw engaged, so I'll be able to line up on that thread and just cut that thread one more time right there. All right, so I'll do that, and I'll bring you guys back once we're ready to build this thing up.
And I'm filming, sorry.
All right, so we're getting ready to do our spray, and I wanted to talk about this real quickly. So one of the features that I have recently added to my Pterodyne that I haven't used before, I think I used it in the last job, but I don't remember if we talked about it. That's this guy right here, the RotoJet. I finally acquired all the pieces that I needed, the RotoJet attachment, the hose, the air regulator and everything. So this is actually the proper way to use this. And whenever you go to spray, you actually turn the air on right here with this valve. So it just blows air out. And I realized that that greatly reduces the amount of smoke that this thing puts out whenever you're using it. In addition to that, it's supposed to provide an even better bond than whenever you're not using it. So I'll be using the RotoJet. I'm going to go ahead and demonstrate it real quick before we get started. This is without the RotoJet. Focus right down here. See all the smoke? Can you see that? With the RotoJet. A lot less smoke when using the RotoJet attachment on that. So we're going to be using that for our buildups from now on. That's our preheat. This is our buildup coat. That's how fast it built it up. We're already right where we want it. That went pretty quick. That's not looking good. I'm seeing a crack right there. You see that?
Yeah.
I think this shaft is bad. That's going to put a damper in our in our plans right there. I didn't expect to see it cracked. Wow. Man. Guess we'll have to figure it out. Man, that's not good. Well, this is certainly an unexpected turn of events on this job right here, and this is not something that I ever expected to see happen during a repair there. But evidently, you know, the heat that we were putting on this thing made this crack come out. The spraying that I did not cause this crack. This crack has already been in this shaft. We just did not see that until I started putting some heat on this thing and it started growing a little bit. But it starts right here at the corner of the Woodruff key and comes across, and then you can obviously see it on the face, and it goes across all the way over to about here. This is where you can't really see it anymore. So, you know, a good, not I wouldn't say half, but a good third section of this part of the shaft right there is broken loose. So that's no good. And I'm going to have to get with Matt. I'm going to show him some pictures of this and let him know, hey man, we've got a bad shaft right here. So the obvious fix to me is to completely replace this shaft. You could probably stub this thing, and I don't know if he's going to want to go that route or not, but you could probably stub it and get it back in operation, but it may not be the same strength that as original shaft would be. You know, this thing has got this pretty complex spline machined on here, and this right here is not something that I'm comfortable with doing myself, nor am I going to put the labor into machining something like this with all these splines on there. I guarantee you that's not something, it's very time consuming when you're not set up to do something like that. I think a proper gear shop, a shop that builds gears and spline shafts every day for a living, they could probably do something like this much more economical than a shop like I can. So I do want to finish turning this out so that we can kind of see a little bit better of what's happening. I like to see how the coating did, but this is not going to work for a usable part right there. So I'm going to come back whenever this is cool and we'll finish turning it. But in the meantime, I'm going to be letting Matthew know what the problem is here on this shaft of his. I'm going to go ahead and get this thing turned. I want to get a little better look at the shaft underneath the buildup here. Want to see if my planned repair was going to work anyway. All right, guys, so update on where we're at on this shaft right here. By the way, I went ahead and got the Woodruff key completely cleaned out, and I want to point out that I went in there, whenever you're spraying over a keyway, the important thing that you need to do when you come back whenever you're done is take a file. I just used a little needle file set, this guy right here, and you go in there and you need to file about like a 45-degree bevel on each of the corners so that you relieve the material that's been built up, in this case the coating. You relieve that so that there's no pressure being applied to that. So you just come in here like this and you just file a little bevel on all the sides, including the ends right there, and that's exactly what I did. All right. You can also see, I'll take a close-up video so you guys can see this. I've got the shaft in there machined to fit the coupling. I've got the Woodruff key cleaned out as well, and I've also gone around and filed all of the edges. So like this edge right here, this other edge, and the ends. You have to take and you got to file those on just like a slight bevel so that the key is not touching the buildup right there. But that's also showing, if you look down in there, I'm trying to get this to focus, you can see the crack. It's all the way around the radius of the Woodruff key to both sides. So it's definitely cracked there because of that. But I do have it machined to fit the coupling as it is right now. But you can also see that the crack originally started in the back side of this Woodruff key right here. That you can clearly see the crack all the way around this radius of the Woodruff key seat. All right, so I spoke with Matt overnight via email, and he he missed this as well. So we both didn't see this until we applied the heat there to it. But what he's thinking might have happened here is that this mill was probably crashed at some time in its life. This shaft, I don't know if I pointed out, this shaft is what drives the vertical head attachment that bolts to the end of that ram on that Cincinnati mill. So that's where there's another coupling that attaches to that, and that's what drives the spindle. So this shaft is actually running that spindle on that attachment there. He's wondering if someone maybe crashed it, causing this crack to form right there. And of course, all of the constant use that it's had with this coupling not being tight and it wobbling back and forth on that key has just compounded the fracture there and made it even worse. So now I told Matt, I think you've got a couple of options there. One is to go ahead and install it like it is, since we've got it fixed, and run it and just roll the dice. I think you got a good chance that it'll work, but you also have a good chance that it may fail at some point there as well. His idea is he wanted me to make sure that the coupling here will tighten down around the shaft just like it's supposed to. And we're going to check that here in a sec. He's thinking that he's gonna get it and he'll make a drawing of this shaft. And once he has his drawing ready, he'll go ahead and reinstall it in the mill and run it and use it. And then in the meantime, have a shaft made, whether that be him that makes the shaft or maybe he subs it out to someone that makes it. Because I told Matt that I'm not interested in making this because of the complexity of these splines right here. I'm just not interested in doing that. But I did the repair that he asked me to do right there. I was also going to point out the fact that I would not be comfortable stubbing this shaft either, which means cutting this off and installing another piece of shaft in there, various methods, screwing it in, welding it in, whatever. I don't feel that stubbing this shaft is a safe fix because of the amount of torque that this shaft end is under there, since it's driving the spindle of that vertical head. I think the proper fix to this is completely replacing this shaft with a new one. So ultimately, that's really what needs to be done to this, is replace the shaft. But that's going to be up in Matt's hands on what he decides to do. But I want to go ahead and fit it and show you guys what it looks like fitted in. So this is a new Woodruff key that he actually supplied. I think I just forgot to mention that. So it fits in there nicely. All right, and then we've got our coupling right here, and then we've got our new key. That's going to be the side where it says balanced right there. Okay. Very little movement on that key, by the way. All right, let me go ahead and take I still haven't taken this shim out of here, so let's go ahead and loosen up the bolt. Take the shim out. All right, there's our shim. Let's go ahead and tighten this up and see if it properly tightens up. Because of that crack there, you know, he's concerned about it compressing and not tightening up properly, which was my concern there as well. Oh yeah, I think it's going to tighten up good around that shaft right there. I'm going to give it a good pull. It's there. I think that's going to hold just fine. Let me go ahead and let's see it spin up. Well, there we go. It's looking good. Running nice and true, about as true as you're going to get it. And I think we have a good fix minus the crack there. So I think this is going to be it for my part of the repair. And yeah, my repair. I'm going to go ahead and get this out of the machine and get ready to send it back to Matt. All right, guys, that's the end of this project right here. We got it out of the machine, obviously, and also wanted to point out, you can see that we have no damage to the threads right there. Still got a couple little spots of the masking that's down in the bottom of that thread right there, but you just have to keep working it and rubbing it and get it out of there. But no damage to the threads, no damage to any part of the shaft right there. Just so unfortunate that crack is in that shaft, causing a whole need to replace that guy right there. But we're going to go ahead and get this thing boxed back up. Matt actually built a really nice little wooden crate for this shaft to set in. It's got almost like little pillow block bearings that hold the shaft in place, and there's a little slot for the coupling to sit down in. It holds everything in place, and then you screw the top down. So we'll get it all crated back up and sent back out there to him. So be sure to check out his channel, Matthew Perlman, on YouTube, because he will have some videos. He's already got one on the teardown of this, and I'm sure he'll probably have some further videos to share of putting it back together, and of course any repair that he does in the future on this assembly right here. So that's it. Hopefully you guys enjoyed, and we will see you on the next project.